Hey folks, welcome to the Level 3 Calculus Differentiation paper from 2023. If this is the first time you're joining us, the way this video works is that I go through each question and let you know what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourselves, and then unpause the video just to see how I go about answering these questions. So, without further ado, let's get started. Alright, so with question 1, what we've got is square root of 3x minus 2. So the way I'm going to write this is I'm going to actually rewrite this as to the power of half, because it's going to make it easier for me to differentiate it. So the next step is I am going to differentiate this, but I'll be using the chain rule for this, which means my half is going to come in the front, 3x minus 2. Now a half take away negative 1 is going to be negative half. Then I've got to make sure I multiply by the differentiation of whatever's inside the bracket, and that is going to equal 3. Now in terms of the answer, I can actually leave the answer like this, and that's pretty much enough for an achieved right there. On to question 1b. And on to question B. So with question 1b, what we've got is find the rate of change. So we've got to differentiate f of t, and then we've got to substitute 1.5 to figure out what the rate of change is. So we're going to do f of t. I'm going to write down f of t first. So f of t is equal to t squared e to the power of 2t. Now what you should notice that we've got to use the product rule for this, because we've actually got two functions that are getting multiplied by each other. So I'm going to replace this with u and v. So u is equal to t squared, u dash is equal to 2t, and then v equals e to the power of 2t. V dash is equal to e to the power of 2t, and I've got to multiply by the differentiation of the power. So in this case, that's going to be 2. So I can write that f dash of t equals u dash v plus u v dash. So u dash is equal to 2t multiplied by e to the power of 2t plus u, which equals to t squared, multiplied by 2e to t. Alright, so the next thing what I'm going to do is I'm going to look for common factors here. Now what I can see is I've got 2 as a common factor, because 2 as a common factor, and then I have just t as a common factor I could take out as well. So if I take 2t out, I'm going to get 2t e to the power of 2t out as a common factor. What I'm left over with is just 1 plus t. Now you can actually leave it like what I've done in the second line there, but the third line just makes it easier to calculate f dash of t. So I'm trying to find f dash of 1.5, so I'm going to go f dash of 1.5 equals 2 times 1.5 e to the power of 2 times 1.5 multiplied by 1 plus 1.5. Now we do need to find the value here, so we're going to actually have to put this all in the calculator. So let's see. Gonna go into main menu, and we've got 2 bracket 1.5 close bracket, and then we've got e to the power of, oh, I think I just messed up there, shift e to the power of, what do we got, 2 times 1.5, so that's going to be 3, and then we've got multiplied by 2.5. So our final answer should be 150.64. There's quite a bit of work to do here for an achieved, but you're going to have to do the correct derivative, which is here, and the correct rate of change, which is here. You've got to do both of these things for getting an achieved. And I guess it's kind of, if you don't get the correct derivative, you're not going to get the correct rate of change. So yeah, it's a little bit of extra work for an achieved, but it is what it is. All right, moving on to question C. All right, so with question C, what we've got is we've actually got the first tangent here. So here is where the first tangent is. Now that tangent is at x equals to 1, which we can kind of see here. So that's x equals to 1. And now a second tangent is drawn that's parallel to the first tangent. So that means this is probably going to be the second tangent here. And what we've asked is find the x coordinate where the second tangent touches the curve. So probably like somewhere here. So yeah, so we've got to actually try and prove what that x value on the green mark is. Now to do that, what we're going to do is we're going to actually figure out what the gradient at 1 is. Once we figure that out, we can actually put it back to the gradient function and should be able to figure out the other x value. So what we're going to do first is we've got y. I'm just going to rewrite this as f of x equals 2 x plus 1 to the power of negative 3. Now you can actually do this as quotient rule, but you're going to create a whole lot of unnecessary work. So I'm going to differentiate this now. So using chain rule, I've got f dash of x is equal to, what have we got? We've got negative 6. So that's going to be negative 6 x plus 1 minus 3 take away 1. And I've got to multiply by the differentiation of whatever's inside the bracket. Luckily in this case it's just 1. So then f dash of x equals negative 6 over, because it's negative 4, I'm going to bring it down to the denominator to make it positive 4. So I've got x plus 1 to the power of positive 4. So this is the gradient function. Now what I'm going to do is I'm going to figure out what the gradient at 1 is. So I'm going to get negative 6 over 1 plus 1 to the power of 4. So I'm going to get f dash of 1 equals minus 6 over 2 to the power of 4. So f dash of 1 equals minus 6 over 16. Which means I can say that the gradient is equal to minus 3 over 8. Now, if you think about it like this gradient right now is minus 3 over 8, which means the pink line's gradient, because it's parallel, it has to be the same gradient, the same slope. So we can kind of say that we want to try and figure out what the x values are, or what is the x value when the gradient is equal to negative 3 over 8. But we have the gradient function. So our gradient function that we have, so if you think about it, f dash of x is this thing right here. So we can say that negative 6, so this is negative 6 over x plus 1 to the power of 4 equals negative 3 over 8. Now this should give us all the x values where the gradient is equal to negative 3 over 8. Now we're going to cross multiply this. So what's going to end up happening is you've got, I'm actually going to do this. So negative 6 multiplied by 8 divided by negative 3 equals x plus 1 to the power of 4. So So all I've done there is I have just did a cross multiplication. So I brought the 8 across, 3 down here, and x plus 1 to the power of 4 across. Cool. So next thing is I've got negative 6 divided by negative 3, that's 2. So I've got 16 equals x plus 1 to the power of 4. So carrying on here, I've got x plus 1 to the power of 4 equals to 16. I've got x plus 1 to the power of 4 equals, now the fourth root of 16 can be plus or minus 2. So my first answer is x plus 1 is equal to 2. And my second answer is x plus 1 equals minus 2. So the first answer, I've got 2 minus 1, which is going to give me just 1. And then my second answer, I've got minus 2 minus 1, which equals to minus 3. Now, if you look at the graph, we've already got x equals to 1. That's highlighted in yellow there. And by pure luck, I've also got x equals to negative 3. So what we're going to do is we're going to write a little statement, and we say, therefore, second tangent. So just writing the statement, second tangent touches the curve at x equals to minus 3. Now grades wise, correct derivative for dy dx and correct gradient of 3 over 8 found, negative 3 over 8 found. Wow, so you've got to do both of these. Man, these guys are getting tough at the moment. You've got to do both of those to get achieved. And for merit, you got to find the correct value of x for the correct tangent. So this part here ends up being a merit. Okay, so let's go to the next question. All right, so for this question, what we've got is a proof question. So we've just got to do parametric equations, well, differentiation, and then put it all together. So let's actually do this. We've got x is equal to 4 cos theta. So we can say that dx d theta is going to equal, now cos theta's differentiation is minus sine. So we're going to get negative 4 sine theta. Now y is equal to 4 sine theta, which means dy d theta is equal to 4 cos theta. So with that in mind, we can actually put down dy dx together. So dy dx equals dy d theta times d theta over dx. So we're going to get 4 cos theta multiplied by 1 over negative 4 sine theta. And when we do this, I'm going to get dy dx equals 4 cos theta over negative 4 sine theta. Now, this is our gradient function. So the first thing that we need for equation of tangent of line is we need a point. So if you think about it like this, you've got y minus y1 equals m times x minus x1. Now we've got y1 and x1 because y1 and x1 is just p and q. So what do we got? Yep. So y1 and x1 is p and q. So x1 is equal to p. Y1 is equal to q, because those are the 2 points that we actually have. Now we need the gradient itself. But the problem is that we actually have dy dx, we actually have it in theta, right? And we don't actually have a theta here, and that's a bit of a pain. However, there is something that you need to notice here. This is one of these really neat, tricky, what do you call it, merit questions. The reason being that is this. If you notice, x is equal to 4 cos theta. And what we actually have is we've actually got dy dx as 4 cos theta. And if you look at the y value, the y is 4 sine theta. So this part here is 4 sine theta. So really, if you think about it, dy dx is actually equal to x over minus y. So this is our gradient function right now, which is x over minus y. So because we have x over minus y, we actually have the gradient function as well, because remember, m is equal to dy over dx. Then because m is equal to negative x over y, our gradient is equal to minus p over q. So now I could write down the equation of straight line. So I've got y minus y1, so I've got y minus q equals m, which is minus p over q, times x minus p. So now it's just a matter of rearranging everything so that I could actually get this particular proof here. So what I'm going to do is I'm going to cross multiply the q, bring it across. So I'm going to get q times y minus q equals minus p x minus p. So I've got yq or qy minus q squared is equal to minus px plus p squared. Now the q squared goes to the right hand side and minus px comes to the left hand side. So I'm going to get px plus qy equals p squared plus q squared. And what I've done there is I've actually completed the proof there. So proof completed is going to get you a merit for achieved correct derivative of dy dx. So up to here, you are looking at an achieved grade. So a little bit tricky, and I guess you kind of have to figure out that that 4 cos theta and negative 4 sine theta at the bottom there, you've got to rewrite that as x over negative y. And if you were to do that, then this question becomes easy. And I think it's a pattern that I'm starting to see with some of these questions now, where you've got to really start looking around for clues. All right, anyway, let's go to the next question. Now folks, this particular question here, it might look actually quite complex, but in reality it's just another area inside a curve kind of question. So what we're really going to do is we're going to break this question down. At the moment, what it says is that we've got this shaded region here. So the shaded region's area is equal to 4m cubed, to the power, it's not cubed, 4m to the power of 4 over 3. Now what we're going to try and do is we're going to try and work out the area of the triangle, and then we just have to show that it's actually 3/8 of the total shaded region. So basically we've got to find what the area of the triangle is, and then show that the green area is actually 3/8 of the yellow area. Now if you look at the triangle itself, we've got a base right there, which is from here to here, so that's going to be x. Then we've got the height of the triangle, which is the same as saying y. But we also know that y is equal to x times x minus 2m squared. So using that, let's actually start writing this question out. So the first thing I'm going to do is I've got area of the triangle is half times base times height. So I've got half times base, which happens to be x, multiplied by height, which happens to be x times x minus 2m squared. So you can expand this, but that's just going to make it super ugly. So what we are going to do is I'm going to split this as a product rule. So I've got a half x squared multiplied by x minus 2m squared. So what I'm going to do is I'm going to use product rule, where this is my first product and this is my second kind of product, well, second part of the product there. So I'm going to write this as u and v. So I've got u is equal to a half x squared. U dash is equal to, now 2 gets cancelled out, and I'm just going to get x. Then I've got, what else have I got? X. Then I've got v is equal to x minus 2m squared. So v dash is equal to 2 times x minus 2m to the power of 1, and multiplied by the differentiation of this, which is just 1. So then I could say area dash or is equal to u dash v plus u v dash. So I'm going to get x multiplied by x minus 2m squared, plus I've got a half x squared times 2x minus 2m. Now what I could rewrite this as x times x minus 2m squared plus x squared times x minus 2m. Now I could actually take a common factor out here. And I am going to take a common factor out. So the first common factor I'm going to take out is, I'm going to do this a bit slowly, folks. So I'm going to take out x as a common factor first. So that is looking at this x and x squared. So when I take x out as a common factor, then I'm going to get x minus 2m squared plus x times x minus 2m. Next, I'm going to take out x minus 2m as a common factor out, which means I'm going to get x multiplied by x minus 2m, and inside the bracket I've got x minus 2m plus x. So this now could be written as x times x minus 2m multiplied by 2x minus 2m. Now this is my gradient function. Now remember, for my area to be max, I've got to put the gradient function is equal to 0. So I'm going to do that on this side here. So a dash is equal to 0 for max, which means I'm going to get 0 is equal to x minus 2m, 2x minus 2m. So I've got 3 numbers that multiply to 0, which means one of those numbers has to equal to 0. So I've got x equals to 0, or x minus 2m is equal to 0, or I've got 2x minus 2m equals to 0. So the first one I don't really have to worry too much. For the second one, I've got x equals to 2m. And for the third one, I've got 2x is equal to 2m. And then x is equal to 2m divided by 2x. Not 2x, just 2, sorry. So then x is equal to m. So I've got 3 values here. X equals to 0, x equals to m, or x equals to 2m. Now if I look at the graph itself here, I'm looking at the graph. Let me just highlight this. So I've got 0 here, I've got m somewhere in the middle, and then I've actually got 2m there. So x can't be 0 or 2m, because that's going to give me a area of 0. So I have to say that x is equal to x equals to m, as x equals to 0 or 2m is going to give you 0. Well, what do you call it? It's going to give you an area of 0. Okay, so I've got x equals to m. So if I go back to my triangle there, the x value is m. So I just need to work out what the area is. I'm going to have to keep using this space. So I've got no more space. Right, let's see. I'm just going to move this here. Give me 1 second, folks. Maybe not. So let's actually go back here. Now we know that the triangle, for the triangle, I've got base is equal to m and the height equals x. I've got height is equal to x times x minus 2m squared. Now because the x value is equal to m, I can say this is m times m minus 2m squared. So I'm going to get height is equal to m times minus m squared, and then the height of this is going to become m cubed. So area of triangle is equal to half base times height. I'm going to get half m times m cubed, which is m to the power of 4 over 2. And finally, if we go to the question, I'm sorry that I kind of worked all the way around here. Let me just put some arrows here. Just terrible space management here. Now I've got to kind of prove that the area of the yellow triangle divided by the green triangle, or actually, if you think about it, 3/8 of the yellow triangle should equal 3/8 of the yellow area should equal to the whatever the green area is. So let's try that out. Let's go 3/8 of the yellow area, which equals to 4m to the power of 4 over 3. So we're going to get 3/8 times 4m4 over 3. That cancels out to 1 and 2. We're going to get m to the power of 4 over 2. And then you can say that, well, I mean, what can you say here? I mean, you've kind of just proven, therefore, area of triangle, or we can say something like, as area of triangle is equal to m to the power of 4 over 2. Therefore, triangle is 3/8 of shaded area, or something along that lines. Right. Super messy question, but I apologize. I'll get better at kind of putting that together. So grades wise, this looks like a double T question. So correct derivative gets you an achieved. That is, I would probably say here is where you're looking at getting an achieved. Correct derivative and x equals to m found, that's going to give you a merit. So getting up to here is going to get you a merit. T1 is area of half. So this is T1 here, m4 over 2. So this is one excellence grade. And then finding out the correct proportion part is your second excellence grade. So a bit of a long-winded question, but a good question though. All right, let's go to question 2, folks. Question 2, what we've got is a straightforward differentiation question, but we've got quotient rule that we have to use. So we're going to put down u is equal to x squared and v is equal to cos x. So u dash is equal to 2x, v dash is equal to minus sine x. So with that in mind, we've got f dash of x equals u dash v minus uv dash over v squared. So we've got 2x cos x minus x squared times negative sine x, and that's all divided by cos squared x. And you can actually leave your answer like this, which means you actually get an achieved grade. Alright, question 2b. Find the gradient for this curve at the point where x equals pi over 12. So we've got f of x is equal to cot 2x. Now cot differentiates to minus cosec squared x, so f dash of x equals minus cosec squared 2x, and multiplied by the differentiation of this, which happens to be 2. So we can say that f dash of x equals negative 2 cosec squared 2x. And now cosec squared is 1 over sine, so I could rewrite this as negative 2 over sine squared 2x. Now I've got to find what the gradient is at x equals to pi over 12. So I've got f dash of pi over 12 equals minus 2 over sine squared 2 times pi over 12. So f dash of pi over 12 equals minus 2, and I'm going to write this as sine pi over 6 whole thing squared. Alright, so I've got negative 2 divided by, let's get rid of that, negative 2 divided by, I've got sine pi over 6. Should have actually put this in a bracket actually. Let's do that. So we're going to put sine and pi over 6. Put that in brackets as well. Pi over 6. And squared. Okay, that does not look right. I must have, thought so. Change that to radians. Let's try that again. There we go, minus 8. That's much better. All right, so let's go to the next question. Oh no, before that, actual grades. This is just an achieved question, by the way, so you do need both the gradient and the negative value to get negative, you need the negative 8 and the gradient to get an achieved. Now I don't get this. I mean, like, look, I don't understand why they just don't give you just achieved for finding the gradient itself, because it's you won't actually get negative 8 without actually getting the gradient part right, which is just weird. Because, I mean, like, I'm looking at this here, right? Like, see how they say correct derivative and correct gradient found. But the reality is that I don't know why you need both. Oh, I guess I know why. Because some people can actually put that straight in the calculator. Right. Okay, that makes kind of sense. Cool. I will actually show you how to do that later as well. All right, let's go to question C. So question C is, we've got a curve, this blah, 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 where the tangent of the curve is parallel to the x-axis. Now, if the tangent is parallel to the x-axis, that's basically saying that we want to figure out when is the gradient equal to 0. That's all. So we got product rule, no, we've got quotient rule here, because we've got u equals e to the power of x, which means u dash is equal to just e to the power of x. V is equal to x squared plus 2x. V dash equals 2x plus 2. So then we can say that f dash of x equals u dash v plus u v dash divided by v squared. So you're going to get e to the power of x multiplied by x squared plus 2x plus u, which is e to the power of x. Sorry, that should be a minus. Just thought about it. Going back to the previous one, did I read it? I did do it right. E to the power of x, and I've got v dash, which is equal to 2x plus 2. And the whole thing is now divided by x squared plus 2x squared. Now we want to actually figure out when is this gradient equal to 0. So all we're going to do is substitute 0. But before we do that, let's kind of simplify things here. Now I've got e to the power of x as a common factor. So if I take out e to the power of x, I'm going to get x squared plus 2x minus 2x plus 2, and the whole thing is divided by x squared plus 2x squared. So the next step is kind of sorting out that bracket inside there. So I'm going to get e to the power of x equals x squared plus 2x minus 2x minus 2, and the whole thing is x squared plus 2x over x squared plus 2x squared. So carrying on here, I've got f dash of x equals e to the power of x multiplied by x squared minus 2 divided by x squared plus 2x squared. Now, because the gradient is equal to 0 when it's parallel to the x-axis, I can put down 0 is equal to e to the power of x squared minus 2 over x squared plus 2x squared. Now cross multiplying this, the denominator just completely disappears. So I've got 0 is equal to e to the power of x or x squared minus 2. So separate them out. E to the power of x equals to 0, or x squared minus 2 is equal to 0. Now e to the power of x cannot equal to 0, so we ignore that. And here I've got x squared is equal to positive 2. And so I can say that x is equal to plus or minus square root of 2. And it's pretty much my two x values where the gradient is 0, or I can say where the tangent is parallel to the x-axis. So grades wise, correct derivative gets you an achieved, and I guess that is going to be right here. And finally, correct values with evidence of derivative gets you a merit, which is going to be this right here. All right, so let's go to question D. So question D, what we've got is find any x values of points of inflection. Now for points of inflection, it's also saying that you can assume that your points found are correct points of inflection. So we can say that f double dash of x is equal to 0. So we've got to try and figure out what f double dash of x is. So we've got f of x equals 3x squared ln of x. So we're going to do product rule here. We've got u is equal to 3x squared, v is equal to ln of x, u dash is 6x, v dash 1 over x. So f dash of x is u dash v plus u v dash. We're going to get 6x ln of x plus u is 3x squared times 1 over x. So we're going to get 6x ln of x plus 3x. And unfortunately, we've got to differentiate this again. We've got, I mean, no matter which way you do, you're going to get a product rule, right? Like, because you've got a product rule happening here because there's got two products right here, 6x ln of x. So you've got to do that one again. Or you could have actually factorized this, take like x as a common factor, and you will find that you're still going to have to do product rule as well. So it doesn't really matter. So I'm going to go back and I'm just going to call this maybe PQ. And I'm going to differentiate just that part there. So kind of to show you here, f dash of x. Let me just do PQ first. P dash. Okay, let's do P first. P is equal to 6x. then P dash is equal to 6, Q is equal to ln of x, Q dash is equal to 1 over x. And the reason I did that was because when I differentiated for a second time, that product rule PQ is going to be written as P dash Q plus PQ dash, and then 3x just differentiates just to 3. I'm going to leave that out as it is. So now P dash is equal to 6, Q is equal to ln of x, plus P is 6x, Q dash is 1 over x plus 3. So I'm going to get 6 ln of x plus 9 plus 3, and I'm going to get, sorry, that should be plus 6 ln of x plus 9. Now I know that f double dash of x equals to 0, so I'm going to put that 0 is equal to 6 ln of x plus 9. Should have actually put that there. F double dash of x equals to 0. 4 points, 4 inflection points. Just a little statement. Then I've got 6 ln of x equals minus 9. Then ln of x equals negative 9 over 6. Ln of x equals negative 1.5. So then x is equal to e to the power of negative 1.5. And I'm going to leave that like that. So for grades, correct f dash of x is equal to an achieved. Correct f dash of x equals to an achieved. So that is going to be right here. And then for merit is the final part, which is finding e to the power of negative 1.5. So we're going to get through question E now. As you can see, my lovely pictures of my helicopter and car is there. All right, folks. So now with this particular question, what we're going to do is we're going to do a couple of things here. So just to kind of explain things, we've got this x direction here, which is the kind of like the horizontal distance from the helicopter to the car. And then we've got y, which happens to be the actual distance from helicopter to the car itself. So this is kind of like the first step we're going to do. The next step we're going to do is we've got 400 here, which is the distance between the car and the vertical height of the helicopter. So those are some of the things that we actually have. Now let's see what we've actually got. Now when the direct distance from the helicopter to the car is 2,500, the angle of depression is at 0.002. So we can actually say d theta dt is equal to 0.002. So I guess what we need to figure out is we can actually connect dy. We need to figure out like what is it? We've got x and theta, we've got y and theta. But really what we want to do is we want to actually try and figure out what dx dt is, because we want to see what's the rate at which the helicopter is actually changing compared to the car. So we're looking for dx dt, because dx dt is going to give you the rate at which the helicopter is actually changing. And if you look at it, because it's, well, not the helicopter is changing, dx is the distance itself, right? So if you think about it like this, your helicopter is flying at 72, but if you find the rate at which it's kind of catching up, then you could go 72 minus that to actually try and figure out what the car speed is. I know it kind of confused you with a lot of things there, but I'll explain as we kind of work through the question, all right? Because dx dt is the distance in which the helicopter is actually catching up to the car. So that's dx dt is change in distance over change in time, is the actual speed. Not of the car, but actually of how close it's actually getting to the car. So anyway, let's have a look at this. So to find out dx dt, we are going to need dx d theta multiplied by d theta over dt. rate of change, right? So what we've got is x 400 and theta. So if you think about it like this, we can say that tan theta is equal to 400 over x, because that is, you know, basic Pythagoras right there, where we've got opposite and adjacent, so we're going to use tan. So cross multiplying this, we're going to get x is equal to 400 over tan theta. We can also rewrite this as 400. Now tan theta is the same thing as saying cot theta, so I'm going to write that as x is equal to 400 cot theta. So dx d theta is equal to 400. Differentiation of cot is minus cosec squared theta. So we can say dx d theta is equal to minus 400 over sine squared theta. So with that in mind, we can actually figure out what dx dt is, because dx dt is dx over d theta multiplied by d theta over dt. So we're going to get minus 400 over sine squared theta multiplied by 0.002. And when we do this, we're going to get negative 0.8 over sine squared theta. So this is the rate at which x is changing compared to t, over t, over the rate of, dx dt. Now the problem is we need to actually figure out what theta is. Now it says that the direct distance from the helicopter is 2,500 meters. So we're looking at that particular moment. So we need to actually figure out what theta is. So if you think about it, the triangle is going to look like this, where this is 400, this is 2,500, and we need to figure out what theta is. So if we think about it, where have we got theta is opposite over adjacent, no, opposite and hypotenuse. So we've actually got sine theta equals opposite over hypotenuse. Sine theta is equal to 400 over 2,500. Then theta is equal to inverse sine of 400 over 2,500. So theta is equal to whatever this is. Let me just pull up the calculator here. So we've got calculators in radians. So inverse sine of 400 divided by 2,500. Now it's going to give me 0.1607. So theta is equal to 0.1607 radians. Now what I'm going to do is I'm going to store this value, because I get a feeling I'm going to use it again. I'm going to store this to alpha t. So basically then I should have alpha t is equal to that. Yep, cool. So that's my theta right there. So I've got my theta. Now I could actually work out what dx dt is. So dx dt is equal to negative 0.8 divided by sine theta squared. So I've got negative 0.8 divided by sine of 0.1607 squared. So let me put this in the calculator. So I'm going to get negative 0.8. Let's get rid of all of this. So negative 0.8 divided by sine, and I'm going to put actually alpha t. Whoa. Sorry, I just messed that up. Apologies. So let's try that again. We're going to go negative 0.8 divided by sine t. So I'm going to put alpha t there, and that's going to get squared now. There we go. That's much better. Okay, so it's actually giving us minus 0.8. Have I done everything right here? Minus 31.25. So we've got minus 31.25. So that means we've actually got to go, the helicopter is actually traveling at 72 meters per second, right? Now, the distance is actually, the rate at which that distance is decreasing is at minus 31.25. So if you actually do 72 minus 31.25, you actually end up with 40.75 meters per second. So car speed equals 40.75 meters per second. So because you've got to think about it, right? We're looking at the instant, at that moment when the helicopter is 2,500 meters away from the car. At that moment, the helicopter speed is 72, but the rate at which the closing of the gap, that's the x, the rate at which that's decreasing is minus 31.25. So that means if you think about it, eventually the helicopter is going to catch up to the car because it's actually going a little bit faster. But at that moment, we've got the rate at which x is changing is minus 31.25. So if you go 70 to take away that, you're going to get 40.75 as the car speed there. Tough question in terms of like how much work you need to do, but yeah, it is what it is. So dx d theta is achieved. Dx d theta, where is that? Dx d theta is achieved, so that's going to be there. For merit, you've got dx dt, so this is merit. Negative 31.25 gets you an E1, and the correct derivative speed of 40.76 is E2. Excellent. That's basically question 2E, folks. Now we go to the next one. All right, folks, for question 3, we're going to get started straight away. So we've got ln of this, so y dash is equal to 1 over x squared minus x to the power of 4 plus 1. And we've got to multiply by the differentiation of the bracket, which is going to be 2x minus 4x cubed. It's pretty much done right there for that question. It's going to get us an achieved, and we can move on. So, question B. I gotta love these types of questions. So, find the values of x where the f of x is continuous but not differentiable. I think the only value I'm looking at is 8 here, because right here it is continuous. It's kind of like going through, but you can't actually differentiate at that value. So that's going to be x equals to 8. Find the values of x where f dash of x is continuous but not differentiable. No, I didn't read that right. Oh no, that's part 1. I was like, hang on a minute, I just did that. All right, find the values of x where f dash of x is equal to 0 and it's concave down. The only point I can look at for concave down is this part here. So this part is concave down, and the gradient is equal to 0 at minus 4. Finally, what's the value of limit as x tends to 6? I can see that it doesn't actually exist, because from one side it looks like it's going towards positive 2. From the other side it's coming towards positive 5. So we're going to say does not exist. Now, to get an achieved, you need 2 of these correct. So 2 ticks to get an achieved. And that's pretty much it for this question. All right, folks. So for this question, we just got to figure out what dy dx is, work out what the gradient is, and then do normal, so which means -1 over whatever the original gradient is. So Let's actually work out what dx dt is. So x is equal to 5 square root of 2 sine pi t over 5. So dx dt is equal to 5 root 2 cos pi t over 5 multiplied by the differentiation of the bracket, which happens to be pi over 5. I am going to simplify this because just know that I'm going to be combining it later. So dx dt is equal to square root of 2 pi cos pi t over 5, because the two 5's actually cancel out each other. Next, I've got y is equal to 10 minus 5 root 2 cos pi t over 5. So dy dt equals minus, the 10 disappears, minus 5 root 2 times negative sine pi t over 5 times the differentiation of the bracket, which is pi over 5. So then I can say dy dt is equal to negative negative cancels out, 5 cancels out, so I've got root 2 pi sine of pi t over 5. So with that in mind, I can say that dy dx is equal to dy dt multiplied by dt dx. So dy dt is square root of 2 pi sine pi t over 5 divided by dt dx is flipped upside down. So I've got square root of 2 pi cos of pi t over phi. Now, my square root of 2 disappears, pi disappears, and what I'm left with is just dy dx. Now, sine over cos is tan, so I can say that tan pi t over 5. So now I need to figure out when t is equal to 6.25, what the gradient is. So at t is equal to 6.25, dy dx is equal to tan pi times 6.25 divided by 5. I'm going to have to try and work this out. So I've got 6.25, 6.25 pi, pi divided by 5. It's going to give me that, and then if I work out tan of this, tan of answer, that gives me 1. So dy dx is equal to 1, which means normal gradient is negative 1 over 1, which equals to negative 1. So grades wise, we're looking at correct expression for dx dt and dy dt gets you an achieved. So getting up to this part here is going to get you an achieved. Gradient of the normal is going to get you a merit. All right, next question. So next question, what we have is find the coordinates of stationary points for this graph, identifying their nature. All right, so we've got to figure out what these values are, and then we've got to actually find the x and y values as well. So quite a bit of work to do, but let's get started. We've got f of x. I'm going to rewrite f of x as x to the power of negative 1 minus 2x to the power of negative 3. So I'm going to work out what f dash of x is. F dash of x is negative 1 x to the power of minus 2, and then we've got plus 6 x to the power of minus 4. Because I'm actually here, I'm actually going to do f double dash as well. So f double dash of x is equal to 2x to the power of negative 3 minus 24x to the power of negative 5. Because we need to find the nature of the points. All right, so the first step is to find the stationary points. Now for stationary points, I am going to do this. So stationary points, f dash of x is equal to 0. So I've got negative 1 x to the power of negative 2 plus 6x to the power of negative 4 is equal to 0. So what I'm going to do is I've got to do this in a way where it's kind of makes sense. So I'm going to do negative 1 over x squared plus 6 over x to the power of 4 is equal to 0. So I'm going to rewrite this as 6 to the power of x over 4 equals 1 over x squared. Then cross multiplying, I'm going to get 6x squared equals x to the power of 4. Then 0 is equal to x to the power of 4 minus 6x squared. Notice how I'm not doing cancelling out the x squared, because if you do that, you actually miss that. You want to be making sure that you actually get the plus or minus value. And I guess you kind of will, because you're going to get x squared anyway. But that's all right. So we're going to get x squared minus 6. So we can say that x squared is equal to 0, or x squared minus 6 equals to 0. X squared is equal to 6, and we are going to get x is equal to plus or minus 6. And on this side, I've got x equals to 0. However, we can't actually have x equals to 0, because if you look at f of x, you're getting 1 over x, and 1 over 0 doesn't actually work. So we're going to put this as x can't equal to 0. So we've got our two values. We've got plus 6, minus 6. No, we've got square root, sorry. Plus or minus square root of 6. That should be our x value. Now the next thing that we need to do is we need to actually work out what the y values are. So we're going to put in x is equal to plus square root of 6, which means the y value, corresponding y value, is going to be 1 over root 6 minus 2 over root 6 to the power of 3. Now, the thing is, how do I do this? Like, putting square root of 6 and kind of doing this is like super painful. So I'm going to show you a bit of a little hack here. So we're going to do square root of 6, right? So I'm going to put in square root of 6 first. And I am going to put square root of 6 as the letter alpha A. So let me show you what we can do. A little trick here, alpha A, right? So then I can do 1 over, so I'm going to do 1 over alpha A. Then I'm going to do minus 2 over alpha cubed. So when I do this, I'm going to get square root of 6 over 9. So y is equal to square root of 6 over 9. So here's my first point, square root of 6 and square root of 6 over 9. When x equals to minus square root of 6, I'm going to get y is equal to 1 over minus square root of 6 minus 2 over negative square root of 6 over 3. See, the thing is, what you can do is now you could actually store alpha as negative square root of 6. So we're going to do negative square root, let's just get rid of all of this, negative square root of 6. And I'm going to store this now, no, not that, store this now as alpha A. So now, if I go back to the previous one and I press enter, I should press enter. How do I do this? Come on. There we go. I think I got my new value there. No, I did not get my new value. I did get my new value because it's negative square root of 6 over 9. Sorry, I did get my new value. Just didn't see it. Because what you can do is in this calculator, because you store values, you can just recall the previous formulas. So my next value is going to be negative square root of 6, negative square root of 6 over 9. Now I need to figure out which one is maximum and which one is minimum. So I'm going to do f double dash of square root of 6, and I've got 2 over x cubed minus 24 over x to the power of 5. So again, and I've got f double dash of negative square root of 6, where I've got 2 over x cubed minus 24 over x to the power of 5. So I'm going to do 2 over, let's actually clear all of this. Go right to the bottom there. We're going to go 2 over alpha a to the power of 3 minus 24 over alpha a again to the power of 5. Now remember, alpha a was actually negative square root of 6. So in this case, I am actually getting positive square root of 6 over 18. But if I go back and actually change alpha a, let's get rid of that minus, put that equals. Now what you'll notice is this is automatically changed now. And I think that's what the cool thing about this is, that I can actually change the variables live. So here, for square root of 6 now, I'm getting negative square root of 6 over 18. So from here, I can see that this value is a minimum, this value is maximum. So we can kind of say maximum is going to be square root of 6, square root of 6 over 9. Minimum is going to be negative square root of 6 and negative square root of 6 over 9. A little bit tedious with the work, but it's not too bad. Correct values of x found with evidence of derivative is going to get you an achieved right here. And merit is for getting both of these correct values and proving the nature as well. All right, folks, let's go to the last question. So with the last question, what we've got is, look, whenever you see like differential equations, something like this, all it's doing there is you've got y there. If you differentiate it once, you're going to get dy dx. Differentiate it twice, you're going to get d squared y dx squared. So that's pretty much our starting point for this question. Let's work out. So we've got y is equal to y is equal to a over 2 e to the power of x over a plus a over 2 e to the power of negative x over a. So if we were to do dy dx, dy dx is a over 2 e to the power of x over a multiplied by the differentiation of the power, which is 1 over a, plus a over 2 e to the power of negative x over a multiplied by the differentiation of the power, which is negative 1 over a. Our two a's cancel out here, and what we're left over with is e to the power of x over a over 2 plus minus e to the power of negative x over a over 2. Hopefully I've done this right. X, yep. That's all looking good. So that's dy dx. Now I've got to differentiate it a second time here. That's to get me my d squared. D squared y dx squared is what I call it, but that's probably not right. So we're going to differentiate this. We're going to end up with the same thing, e of x over a over 2 multiplied by the differentiation of the power, which happens to be 1 over a. Then we've got minus e to the power of negative x over a over 2 multiplied by negative 1 over a. So here we're going to get e to the power of x over a over 2a plus e to the power of negative x over a over 2a. That's looking good as well so far. Okay, so getting up to part 1, reaches either stage 1 or stage 2, gets you a merit. Correct expression for dy dx is achieved. So this is what you're going to get. Achieved up to here, merit up to here. All right, so let's have a look at the differential equation. Now the differential equation basically says this. We've figured out what this part is because that's literally this entire thing here. We also have dy dx, which happens to be this thing here. So now it's just putting everything together. So we're going to do the left-hand side first, then we're going to do the right-hand side. So let's do the left-hand side first. Now that is a times d squared y over dx squared. So we're going to get a times e to the power of x over a over 2a plus e to the power of minus x over a over 2a. The a is kind of, I can rewrite this as like this. E to the power of x over a plus e to the power of negative x over a over 2a. The 2a's cancel out. And I've got e to the power of x over a plus e to the power of negative x over a over 2. Now this is the left-hand side. So the left-hand side kind of works out real nicely, but the right-hand side is going to be quite horrible. I'm not going to lie. We've got square root of 1 plus dy dx squared. That's going to be a lot of fun to try and work out. Dy dx squared. Jeez, that is brutal amount of work. Okay, here we go. So what we've got is we're going to basically substitute the green part, which is the e to the power of x over a over 2 minus blah, blah, blah. We're going to put that in there, and we've got to square it. So that's going to be, I think I'm going to need so much space to work for this question. So I've got 1 plus, I'm going to put the green part first, which is e to the power of x over a over 2 minus e to the power of negative x over a over 2. And because it's squared, e to the power of x over a over 2 minus e to the power of negative x over a over 2. And now I've got to actually expand the bracket here. So to expand the bracket, I've got 1 plus, so basically I'm expanding it like a little quadratic, right? So let's do the numerator first. For the numerator, I'm going to get e to the power of 2x over a, e to the power of 2x over a over 4. Then I've got, this is just nasty question. This is such a horrible question. Then I've got e to the power, so that's going to become a minus. Let me just see if that's correct. What have I missed here? When the two powers get added up, they disappear. Yeah, because they disappear. Because e to the power of negative xa times e to the power of positive x over a, that's just going to become 1. Because that's going to become e to the power of 0. Oh, right. So this is going to become minus e to the power of 0 over 4. Then I'm going to get minus e to the power of 0 over 4 again. And then plus e to the power of negative 2x over a over 4. God, that's horrible. That is absolutely horrible. So 1 plus e to the power of 2x over a over 4. This is going to become quarter, another quarter, and finally plus e to the power of negative 2x over a over 4. So I'm going to get 1 minus half. But before I do that, I've got plus e to the power of 2x over a over 4. Quarter and quarter makes a half, so it's minus half, plus e to the power of negative 2x over a over 4. Getting there, slow and steady. Then I've got square root of 1 minus half is a half, plus e to the power of 2x over a over 4, plus e to the power of negative 2x over a over 4. You have got to be kidding me. And now somehow I've got to actually get this right hand side to look like this. Now I'm going to try to pause to try and explain this. I have to say this is truly an evil question. I don't usually say that very often, but this is a horrible question. Now you're sitting there, how am I supposed to factorize this, right? And this is so annoying. But the clue was actually given right at the start there. And I don't know, I mean, I can see it, but trying to explain this is just insane. Negative, positive. Okay. I think I got it. I got it. Let me try this, all right? So look at this particular one right here. I'm gonna have to choose a different colors here so I can show you folks. So when I did this bracket times this bracket, all right, imagine it like this. I've actually gone something like a minus b times a minus b, and what that's given me is, if I keep going down to here, that's given me a squared minus 2ab plus b squared. So I'm trying to match up all of these things, right? So that's the middle term, that's the outside term. So you kind of have to think like that, because I'm going to rewrite the bottom part here. Now watch what happens if I do this. If I rewrite this, I'm going to get e to the power of 2x over a over 4 plus half plus e to the power of negative 2x over a over 4. Because what I've done here now, I've actually got a squared plus 2ab plus b squared. Because the only difference between these two lines here is the negative half and the positive half. Which means I should be able to rewrite this here as e to the power of 2x over a over 2 plus e to the power of negative 2x over a over 2 squared, like that. But it won't be e to the power of 2x, it'll actually be just e to the power of x. Because remember that the powers actually get added up. And I hope you can see that pattern there. Because what we've done here now is we have rewritten this as a plus b squared. Now a squared has e to the power of negative 2x, which means a will have e to the power of just 1x. Now we can take the square root out, and we're going to get e to the power of x over a over 2 plus e to the power of negative x over a over 2. And basically what we've done is we've actually shown that left hand side is equal to the right hand side. That is just a horrible question. But let me just check if I've done that right. No, I'm fairly confident that proof is correct now. So, and I guess that the trick part is actually seeing the a minus b, that expanding the bracket and then bringing it back again the other way. That is such a, honestly, that is such a cruel way to do this question. But in terms of excellence, stage 3 you can get a E1, and I guess the stage 3 part is up to here. You can actually get a E1, and then for your final proof you actually get E2. Horrible question. Evil, horrible question. But that's pretty much question 3 there, folks. All right, folks. As you can see, that was a pretty long question. Some of the excellence questions, I have to say, those 3 excellence questions were quite, especially the last one was quite horrible. I'm not gonna lie. The second one wasn't too bad, but I feel like the first one was the bankable excellence question. That was the easy excellence question, the triangle one. But number 2 and number 3, question 2 and 3's excellence questions were quite, they're quite tricky. But yeah, I don't know. The rate of change one might have been not too bad. But anyway, folks, look, if you have any comments or questions, just put it in the comment section and I'll try and get to them. Also, there is a differentiation in 15 hours playlist, which I'll try and tag here. That should be great revision. Like, it's a good starting point. Especially don't jump into the exam paper straight away. Watch that playlist. It's about 15 hours. It's got some good stuff in it. As for the paper itself, the achieved parts was quite straightforward. I think it was easy to get achieved, but I think excellence, you have to get that area question correct. Because looking at the cut scores, excellence was only actually 18. Excellence was a 19. Wow, that's yeah. As you can see, that's a good indication that this paper was quite a tough paper. Cool. That's it from me. There should be something popping up.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.